If A is the first term and R is a common ratio of a geometric progression, show the sum of the first n term is Sn equal to ARn minus 1 over R minus 1. So we need to show how to get the formula. So first of all, we will take Sn equal to first term plus second term plus third term plus so on and so forth until n term. And then Sn, we use the formula is A for the first term AR, for the second term AR2, third term ARn minus 1, right? The n term. So we will times with the R. So it becomes A times R R squared, AR cubed, and ARn. Right, so after that we have 1 and 2. Okay, the 2 is we got from multiply R with the each term from the 1. Now we need to subtract 1 and 2. We minus, so Sn minus R Sn. We will get this term minus this term. Finally, we factorize the Sn and we simplify, we will get this thing. A minus ARn looks very simple because we can cancel out them. Like this term, we cancel. This term, we can cancel out, and so on and so forth. All the term we cancel in between. And finally, this term also cancel out. So balance is just A minus ARn. So we factorize the A, we will get this formula. Okay, so we have proved the Sn is equal to A bracket 1 minus Rn over 1 minus R. Let's go through again. First step is you list out the Sn by adding term by term, T1, T2, T3. After that, okay, you write the formula. You get equation 1, then you times with the equation 1 with the R. Remember, multiply each term by R. After you multiply by R, you will minus 1 and 2, and you will simplify to the simplest form, sum for the first n term. This is a syllabus for the proving of the Form 4 syllabus and also Form 5 syllabus. So I will start with the first proving, start from Form 4. Given that function fx equal to x squared and the x is greater or equal 0 and gx is equal to negative square root x and the range of x is greater or equal 0. Find composite function fgx and gfx, hence determine whether gx is the inverse function of the fx or not. State your reason. This kind of question is called proving. So, solution. First of all, we have to start with the fgx is equal to the function f with the object gx. Alright, and we will substitute the function gx, which is negative square root x, inside, and the whole function will be square, and we will get fgx equal to x. Alright, first thing we will start with this fgx equal to fgx, and then let's go to the function given. Gx is negative square root x, so we will substitute in. Need to square the whole function of the gx. And if we simplify negative with square, we get positive, right? Square root x times square root x, you will get x. So that's why you prove that you got fgx equal to the x, which is the object. X is the object. Gfx. Okay? Composite gfx. And then the gfx, the function gx is given here, right? It's negative square root x. So we have to use the function g, and we will substitute the fx. Fx was given x squared, right? Here. So the object now is a fx, and the function is a g. So negative is there, we will get negative x, right? So the gfx is given answer negative x, because gfx not equal to x, right? So gx is not the inverse of the fx. So in order to prove that it is the inverse of the fx, we must show that we will get x. Since we are getting g of x is equal to negative x, so conclusion is gx is not the inverse function of the fx. The first proving is proving the fx equal to x squared and gx equal to negative square root x. Find fgx, find gfx, and then determine that gx is the inverse function of fx or not. State your reason. So we found out that gx is not the inverse function of the fx, because if it is the inverse, you will get the x.